Welcome everyone to this webinar, Building with Nature, where we're going to explore regenerative design and building with Earth. Who are we? The RCSA is a non-profit organization focused on transforming our built environment into a regenerative one. We promote strategies and approaches that bring regenerative design and construction to life. We really try to work collectively to inspire, educate, and create awareness and contextualize regenerative built environment approaches to the South African context. And we make an effort to showcase local projects, local people, and local companies that are aligned with our goal, which is creating a regenerative future. And if you've missed any of our previous webinars, everything is on our YouTube channel. We usually try to upload the latest webinar within a week, and we'll send you the link, but definitely within 2 weeks. And all our webinars since 2020 are available from our YouTube channel. So, and when you get there, please subscribe to our channel. It helps us getting sponsorships by having more subscribers. Similarly, follow us on Eventbrite. That's our registration platform, which you probably have where you're registered for this webinar. If you follow us there, you'll get automatically an email when we upload a new webinar, so you can register immediately. Follow us on our LinkedIn. That's the most up-to-date what's happening for that month, or reach out to us on our emails. But we've seen a steady climb in our subscribers and followers, so that's really great. For this webinar, a really special thanks to South African Institute of Drafting. They waived the validation fees for this webinar, so we really appreciate their support for this webinar. So, to the order of the day. Today we are discussing building with nature, as I mentioned, and we have two really great speakers lined up, which will complement each other really, really well. First up is Milan. He's also one of the volunteers of the RCSA, but he was willing to step in today as a speaker. He's a sustainability professional and biomimicry consultant, and he's driven by the belief that nature-inspired innovation is key to solving environmental challenges. He's got a dual master's degree, including a Fulbright-funded Master's of Environmental Sustainability from Indiana University and a Master's of Urban Studies from Wits University, and his undergrad is in civil engineering. He has pioneered research in the Living Building Challenge in South Africa and combines practical technical skills with ecological creativity to develop regenerative solutions. His true passion lies at the intersection of complex system thinking, biomimicry, and nature connectiveness. So Milan is going to set the scene with slides and providing a framework talking about living buildings. And then after that, we have Xavier Huybrechts, and he will present a more practical case study to us, a beautiful lodge, Witklipfontein, which I've been wanting to have on this webinar for quite a long time, so I'm really happy he's here. He's a principal designer and senior partner at GLH Architects. He's trained in Brussels and then moved to South Africa to become an architect. He's got extensive experience across commercial, residential, and mixed-use development. He brings both architectural and urban planning expertise to his work. He's got a meticulous eye for detail and design and ensures that every project reflects a balance of functionality, beauty, and environmental sensitivity. He's worked on landmark projects that explore innovative, context-responsive design approaches, including the celebrated Witklipfontein Lodge, built with rammed earth as a model for nature-based and regenerative architecture. I'm really happy that he's here. We go back quite a long time. We did the first certified building in South Africa in 2009. So welcome, Xavier. I'm happy to have you here today. But I'm going to first hand over to Milan to present on regenerative design and systems thinking and living buildings and all the exciting stuff.
Cool. Well, hello, everybody. As Malu said, my name is Milan Master, and I'll be presenting on building with nature and exploring regenerative design in the process. So before we continue, I'd just like to do a quick land acknowledgement, in that we honor the ancestral stewards of this region and the more than human communities that have long sustained it, including the indigenous plants, animals, and ecosystems that define its unique biodiversity. And we acknowledge that we gather and work on the traditional lands of the Khoikhoi and San peoples, the first human custodians of this high-veld region. These communities have lived in deep relationship with this land, its mountains, rivers, and grasslands. And we recognize the interdependence of all living systems and the responsibility shared by present and future generations to protect and care for this land with respect and reciprocity. So I want to take this time just to sort of give a bit of background and acknowledge also the lineage of knowledge of what I'm going to be presenting today. As Malu said, I've got an undergrad in civil engineering and a master's in urban sustainability from Wits. I've got an environmental sustainability master's from Indiana University. And through that process also, I've interacted with a lot of institutions such as Learn Biomimicry, where I got my biomimicry practitioners from, as well as a lot of the information that you're going to see today comes from Biomimicry 3.8, Biomimicry Institute, and the Living Future Institute. On the left are just a whole bunch of people that truly inspire me and have also helped me on this journey and have truly been mentors and guided me along the way. So I truly appreciate it. On the top right there was the Bioneers Convention earlier this year. I got to meet Janine Benius, who's sort of the grandmother of biomimicry, and just a little shout out to the graduation that I had earlier this year as well for my master's in the US. So yeah, like I said, what I'm going to be presenting today comes from a whole host of different people, a whole host of different organizations, but they've definitely shaped where I am today. So, all right, let's start. So everyone these days talks sustainable, but what does sustainable really mean and what does it indicate? As the late Claire Yenish used to say, well, sustainability means that we're just sustaining what already is there. So we're not necessarily changing it, we're just keeping it already as is. But how do we move beyond that? Well, if we go a little bit back, a lot of what we currently doing and aiming towards sustainability, some would say is just this process of doing less bad. But if we push beyond that and move away from sustainability and more towards regeneration, then there could be, you could say that we're actually doing more good. So how do we move from conventional practice, which is just the minimum standards, to more green and high performance buildings that are our common sustainability ratings, all the way to restorative design and even regenerative design, where we're actually designing with nature at the design table. If we're looking at the built environment though, our building standards such as EDGE, I would say, are, on that end of doing less bad. Yes, we are creating more sustainable buildings, but adding low flow taps, for example, is not necessarily changing how we interact with water and the dynamics and where that water goes or how that water comes into the building. So yes, we're doing less bad there. But if we shift over to that pivotal point of moving towards more regenerative design, that's where things like the Living Building Challenge come into play, where we actually look at a building as a living system and how does it operate within the ecosystem that it's in. And I've added an image here on the right that was the meant to be Fynbos building, the first biophilic building that was meant to be built in Cape Town. But just this year also, that very design has been, well, the company has been bought over and the designs are changing. And so I also question you and want you to think, like, are we actually ready to move towards regeneration? Or, is the market ready? Is what they said when, unfortunately, this building is not going to come up anymore. But just to think about that, are we truly ready for regeneration? But some would argue that we are, and that's where the Living Building Challenge comes into play. And so what is the Living Building Challenge, and what does good really look like if we need to move away from less bad towards more good? Well, the Living Building Challenge is a philosophy, an advocacy tool, a certification program that defines today's most advanced measure of sustainability and regeneration in the built environment. When Jason McLennan first developed the standard, he said, well, what if buildings behaved like a flower, for example. And what would that look like? What would this building in its ecosystem do with the water, waste, energy, and beauty of it all? According to their website, I just want to mention that the Living Building Challenge is done through the International Living Future Institute. And they say living buildings are regenerative buildings that connect occupants to air, food, nature, light, and community. They are self-sufficient and remain within the resources of their site. They create a positive impact on humans and natural systems that interact with them, similar as a flower would. But what does that truly mean? Well, the Living Building Challenge comprises of 7 performance categories known as petals, which are divided into roughly 20 imperatives in combination of them all. And these imperatives are applied to every type of building project, no matter the size or location. All imperatives must be met in order for the project to qualify as a living building. And what might these petals be? Well, the first one is water. And they look at the sort of the priority of net positive water. So there's a lot of talk these days about net zero and getting to net zero. But net zero just means that basically all of your inputs are equivalent to all of your outputs. Net positive says, well, how do we contribute more than what we're actually taking in? So with this imperative, what it requires is an avoidance of potable water for irrigation, for example, a significant reduction, almost 50% of your water use from your baseline model, and complete management of your stormwater on site. So looking at that flower again, for example, what does it do with its water? It collects everything on site, it treats everything on site, and releases it back to the environment. So what if our buildings could do that? What if our buildings could utilize the water on site and contribute back to its surrounding ecosystems? The next petal looks at materials. And for this one, it's quite interesting that it says it should be safe for all species through time. So if we look at most of our building materials today, through its manufacturing processes, can we actually say that through the entire life cycle that these materials are beneficial for everybody involved, for all humans and non-humans involved? It's difficult to say. But the intent of this petal, though, is to foster a materials ecosystem that is non-toxic, transparent, and socially equitable. The imperatives in this section aim to remove the worst known offending materials and practices. And they do this by something called the red list, which is a list of chemicals and materials that are really bad for both humans and the environment. And it's also to acknowledge this obligation to offset damaging consequences associated with the construction process. A lot of the carbon that's associated with it, and what do we do? How do we offset all of these things? The next petal then is place, which I find is a really beautiful petal, and that's restoring a healthy interrelationship with nature. So this petal really aims to realign the relationship with projects and people to their natural environment. Again, looking at that flower, like it's really rooted in place, and it's interrelational with the other plants around it. And how do we do that? This petal truly articulates where it's acceptable to build and outlines how to protect and restore the site. How do we create pedestrian-oriented communities and encourage local agriculture? How does it benefit not just those inside the building, but those outside, the society at large? The next petal is energy, and going back to net positive energy. It's not just creating 100% of renewable energy, but 110%, 120%. How do we give back to the grid, to our surrounding communities? And this petal signals a new age in the built environment that relies solely on renewable forms of energy, that operates year-round, and that does not emit any pollution. So what's this reduction and optimization of energy use that's prioritized in order to eliminate wasteful consumption and resources? So again, looking at the flower that takes all of its energy from the sun, it doesn't need sort of any of these other avenues of energy to extract from. So how do we design our buildings that utilize that? And just a quick mention of the picture on the right is the FIPS exhibit staging center. And as I'm going through these, just look at how the water is utilized. Look at the amount of solar panels and where that energy is coming from. For a building of that size, it doesn't necessarily need that many solar panels, and yet most of that energy is being used on site and also being given to the surrounding community. The next petal, which is also quite interesting, is equity and supporting a just and equitable world. So the intent of this imperative is to allow equitable access and protections from any negative impacts resulting from building a living building. So all externally focused roads and non-building infrastructure must be equally accessible by all members of the public, regardless of background, age, ability, or class. So for example, including the homeless, with reasonable steps taken to ensure that people can benefit from the project's creation. So we're not just building a building for the sake of building a building. We're building a building that actually contributes to everybody, that everybody has access to it, irregardless of where they come from or how they associate with that surrounding infrastructure. Health and happiness, which is quite nice because it optimizes well-being. So again, taking this perspective from somebody who's actually going to be in and around the building. And the intent of this one is to promote good indoor air quality and a healthy interior environment for project occupants, to demonstrate ongoing high indoor air quality. Because are we actually cognizant of the air that we breathe? Sometimes not really. It's sometimes always, we get clean air outside of the buildings, but what if we could get clean air inside the building? Outside views of daylight must also be available. And this also leans into the whole biophilia approach of connecting us to nature and the broader scheme of things. And last but not least is the beauty petal, or uplifting the human spirit. And projects must contain sort of intended solely for human delight features, which celebrate culture, spirit, and the place in which it is in. So projects must incorporate public art, and teams must conduct biophilic workshops so that they have a biophilic framework. And again, coming to that aspect of a flower, that's, it's difficult to find people who don't find flowers beautiful. And in its raw natural form, there's true beauty there. And what does that mean in a cultural and societal context? This is what regenerative buildings should be. They should maintain all of these petals at all the different levels. But if we step a bit back from that, what is it really trying to teach us? Again, saying, well, how can we design a building that behaves like a flower or a plant or any other organism in its ecosystem? How do we design a building that contributes back to its surrounding ecosystems, not just being rooted in place, but also contributing to social systems, to other ecosystems? And how do we design a building that functions like nature? So I put a little graphic at the bottom there of, imagine how cities could function like forests do, and capture the water and capture the carbon and recycle it and ensure that it's a closed loop system. Humans are the only species that creates waste. In the natural world, there is no such thing as waste. So how do we take all of these streams and utilize them? And if we do step back then, and we look at this idea of looking at functions in nature, well, then I'd argue that at a broader scale, that's what biomimicry is. And so I'm going to give you a quick and brief introduction into what biomimicry is. But biomimicry is basically this practice of learning from emulating nature's genius to solve all kinds of different human challenges. It's had 3.8 billion years of brilliant designs and strategies just waiting to be explored. Nature has all of the answers that we're looking for, so why not just look for them there? It's about learning from nature and how nature creates the conditions conducive to life. Do we as humans know how to create the conditions that are conducive for a living environment? Some would argue yes, but some would argue not. And Janine Benyus, who I mentioned earlier on, in her book, Biomimicry, this is one of the quotes she said. She said, when we look at what is truly sustainable, the only real model that has worked over long periods is the natural world. So what can we learn from that? Well, there's different ways in which we can emulate that, in which we can look to nature. And the three most fundamental ones are form, so actually emulating the form of nature. On the right here, we have the Eden Project in the UK that looked at bubbles and how natural bubble formations actually create structures that use less materials and actually space efficient. And that's how this project was created. We can look at processes. And have you ever thought about how spider webs are made? I mean, they're made at ambient body temperature with natural and organic chemicals that create a material that's stronger to steel. Like, just think about that for a moment. And how can we actually use those processes to create materials that are far stronger than what we have today at ambient temperatures with recyclable materials? And we can look at systems. not just looking at individual components, but entire systems. And the project on the right is actually a schematic done by Michael Paulin, who will actually be presenting at this year's Green Building Convention. And he did a study of something called cardboard to caviar, where they found farmers could actually create entire networks of systems where this man converted waste cardboard into a caviar business through a multitude of streams, but realizing again that there is no waste in nature. So how do we convert those streams into something that can actually become profitable and beneficial for everyone in the process? Well, at its crux, biomimicry has three essential elements, or seeds as they call it. It's called ethos, reconnect, and emulate. Ethos being the true form and essence of our ethics, our intentions, our underlying philosophy of why we practice biomimicry. And I think that just goes with anything. I put this little video on the side here of this little machine that was created in one of the Avatar movies. And it sort of mimics what a crab would do, but it was used for very destructive purposes. And so I argue, like, you know, what is the true intent about what we can do? There's a way in which we can be extractive also and take all of these ideas for our own selfish needs, but let's shift that lens a bit and let's become a bit more regenerative and cognizant of what we're doing. There's a reconnect aspect of it, and that's reconnecting is the practice and mindset that explores our deepening relationship between humans and the more than human. So that fundamental aspect that we can't just go into nature and extract the solutions that we need, but actually understanding that we need to build a relationship with the natural world. And finally, emulate, which I think most people are familiar with, but then how do we take these functions that we see in the natural world and apply them to our human needs? How do we bring these principles, patterns, and strategies and focus them into our informed design? At the core of this is something called life's principles. So these principles are a set of principles that are found consistently in just about every organism and ecosystem around the Earth. So life has evolved a set of strategies and have sustained over 3.8 billion years. And this can therefore be considered as winning strategies for surviving and thriving on this planet. So they're also a set of innovation principles that are beneficial to organizations or designs, whether you focus on sustainability or not. So if we use life's principles as the benchmark, well, then surely everything around it should be regenerative. And I'm going to run quickly through it. I am a bit cognizant of time. But just to run through each of those life's principles, for example, adapting to changing conditions. And you'll see under each of them, there are a set of sub-principles, such as incorporating biodiversity. So imagine if your design incorporated biodiversity. I've also given you examples. So for example, the One Ocean Pavilion that was done in Expo 2012 was inspired by shark gills and by sea anemones and how they open and close. And so imagine a facade that opens and closes depending on air regulation or light. So how do you adapt to these changing conditions on the external conditions, and how does your building adapt to that? The next life principle is to be locally attuned and responsive. How do we leverage feedback loops and cyclical processes? This image here, and I apologize for my pronunciation, but the Institut du Monde in Paris actually create an entire facade with these multiple rings that were based on the iris and how apertures would open and close depending on the amount of light that eyes require. And so that was adapted again into a building of like allowing the different amount of lights to come in depending on what is required. How is that locally attuned and responsive to the light that's around it? And then using life-friendly chemistry. I mean, organic chemistry, there's sort of about only 8 true elements that are used throughout nature. And how do we utilize that? How do we use chemistry that's benign in water or that breaks down into useful components? This is the living seawall in Sydney. And they actually looked at mussels and mangroves to see how those attach into the ground or onto rocks, and created a very organic glue in which then they create an entire seawall in which other organisms could benefit from this wall in the ocean. We have the next principle, which is being resource efficient with materials and energy. How do we fit form to function? I think it's very easy to say, yes, we're going to fit form to function, but does that form actually produce the function that it needs to be? This is a very classic example in Zimbabwe. It's the Eastgate Center. And Mick Pierce, when designing this, looked at termite mounds and realized that airflow through these mounds, requires very minimal energy because the airflow, it fit the form to function. And so he used this and designed it here. And 30 years later, this building still has very minimal air conditioning requirements just because of the function of the building. We have got integrated development with growth. So how do we self-organize and combine modular nested components? This is the hi-fi sort of structure in New York that used sort of mycelial networks to build from the ground up. How do we take this idea and use nature in a beneficial way? And finally, evolve to survive. It's a fascinating project called the Al Bukhar Towers in Abu Dhabi. And they looked at how sunflowers would rotate and follow the sun and close and open depending on the amount of light. And again, looking at facade design, what do we want in, what do we want out, and how do we bridge that gap? How do we reshuffle this information and integrate the unexpected? Again, bringing this back to the living building challenge. Look at the beauty behind it. Look at how it integrates with its surrounding environment. And this is just a quick mention that this can be applied throughout the entire life cycle of all the building processes. Like, think about the extraction of materials or the transportation of materials. Think about how we create our buildings, And again, just reminding us that it's not just the form processes and systems at an individual level, but this can be scaled up in a larger level. The image on the left shows the Abuja smart city that was designed with biomimicry principles. As you can see, there's no straight lines necessarily in nature. So why do we design our streets and our cities like that? Why not combine them into systems that actually work and create, living systems? And then finally, if we're looking to projects that are built with the natural environment, so built with Earth, for example, why don't we look through those projects through the lens of life's principles? So, for example, this indigenous building that was built as a cultural center in Canada was built with rammed earth. And so if we look through these principles, what can we say? It's actually locally attuned. It's resource efficient. It's been evolved to survive in those conditions and uses life-friendly chemistry. So I implore you now to take these principles that we've gone through and apply them to any project that you might see, including Xavier's coming next, and just see where these apply. How can you take these examples going forward? For example, here also the termite mounds and even the ovenbird uses very similar techniques and material. So nature is doing it already. We just have to shift that lens, shift that viewpoint, and look to nature for what we need. So what is our design brief going forward? Well, let's look at the genius of place. Where are you located right now? Go outside and understand your local ecosystem. What plants, animals, and ecosystems have developed there? How have they adapted to survive in those systems? And then think to yourself, well, does the building that you're living in and the materials and the group of buildings that surround it contribute to the local ecosystem? Likely not. But how do we change that? And how does this not just benefit us, but the more than human, the natural ecosystem around us, and those that also occupy the space with us? And does it meet life's principles? Because if we design everything that meets life's principles, then surely we'll be more regenerative and in tune with the planet. So just wrapping things up again, how do we build with nature? What is regenerative design? Well, I would say, look at what function you're trying to solve, whether it be thermal regulation or water purification or just building a house. Look to which organisms in your local habitat perform a similar function. For example, those pesky wasps' nests that are hanging under the roof. Well, isn't that also a habitat? Look at how those materials are being used. Look at how that is constructed, even upside down, and it still holds strong. And then look at your design and say, does my design meet all of life's principles? Am I in tune? Am I like the flower of the living building challenge that is rooted in its place? And am I contributing back to its local environment? Am I contributing back to the natural and social ecosystems? And I'll leave you with that. Thank you.
Thanks, Milan. That was very inspiring.
Yeah.
And nice to see the Linden Playhouse there. That's a nice local project to showcase. All right, so we're gonna move over to Xavier.
Our dream was to create an eco-lodge that was combining vernacular building techniques with a modern minimalistic design. Being in a World Heritage Site, it was evident that we had to build in a more respectful manner. The lodge was therefore designed to blend and disappear in the surrounding nature. The ground carpet at the bottom of the hill was lifted a little, just enough to slide the house under it. Building with earth became obvious. It has been around for as long as mankind has been building. The soil that comes from the site requires no transport and no transformation. Thick earth walls take advantage of the large daily amplitude, regulating temperature in summer as much as in winter, avoiding air conditioning. By removing cement or earth building will one day return to nature, a little like a sandcastle erased by the tide. Inspired by old ruins in the area and people across the world, our project became a lab for experimenting with different earth techniques, from stone and mud to rammed earth, compressed earth bricks, earth bags to straw and soil plaster. This, combined with waste granite, scaffolding planks and homemade paint to name a few, has made for a raw and rich living environment. Another achievement was, I believe, our decision to build the house ourselves only with the help of a few unskilled laborers, and in so doing, teaching them the building techniques we wanted to implement. This took a little longer, but had more benefits. We believe that through this project, we demonstrated that building differently is possible, closer to nature, closer to the people, enriching both. We hope this will inspire others to do the same.
Okay, so building with earth. So I'm going to try to be a little more practical. I mean, it's a very practical project that's born out of a passion. I'm more known for working in the corporate environment and large building environment, but I've always had a passion for buildings that really incorporate or work better with nature. And this opportunity presented itself, and we really dived directly into how to build with earth. So building with earth has been around forever. I'll show you 3 examples. About 70% of the Great Wall of China is done in earth, not in stone, and it's been around for thousands of years and strong, and so it's been around for a long time. So this is in Mali, the Great Mosque, again a building that's been around for hundreds of years and surviving its time. And you can see that this shows that a building with earth needs a little bit of maintenance, and that's why you've got all those sticks sticking out, because that's how the people access the building every so often, to reclad the building with a fresh layer of earth or mud to keep it in its pristine condition. So this is quite impressive in Yemen, and this shows you that how we always think that building with earth is low and short buildings and so forth. Here there are 16-story buildings that have been there for about 400 years that are still standing, and you can see those are today's pictures. They are still in a good nick, and they are 400 years old and 16 stories tall. Obviously they've got big walls, but so building tall is definitely possible in earth also. So the why building with earth, or why did we stop building with earth, and why is it now seen as substandard, and why do we only see it in rural areas? You have to know that still today more than 50-60% of construction in the world is still with earth, but it's obviously not in city environment, it's in rural environments. And why haven't we never brought that technique into building our cities? Even in South Africa, it's seen as a postman construction. And if you go to somebody that comes from a village that is built with mud, and you ask him, what do you want? He will probably say, I will want a house with bricks, tiles, and 2 columns in front. Not realizing that the perfect material is what he had from his previous generation, and that actually people are forgetting, and are forgetting how good and in tune with nature and good for living into, because it was well insulated and so forth, how all those old vernacular buildings were actually responding to the climate much better than the shacks and the small houses with poor insulation and so forth. So on the Highveld, we've got a very specific climate, and the main thing that I would like to highlight, because it's going to help with the building with earth, is the daily thermal amplitude. So we've got a very high daily amplitude between day and night. So the temperature at night on the Highveld is about 10 to 15 degrees, consistently lower every single day of the year. So you can see that difference in the winter, but you can also see it in the summer. Now, obviously, the closer you go to the sea, that goes down, except in the Namibian desert, where the amplitude is massive. So deserts is where you've got the most amplitude, and as you get to more temperate type of climate, it gets very flat. So the thermal mass that I'm going to speak to you about now is not really applicable in a Durban climate, for instance. I mean, that doesn't mean you shouldn't build there with earth, but this principle doesn't really apply there. So thanks to that daily amplitude, what you can do is use your walls as thermal mass and capture the coolth of the night in the summer to cool during the day, and in the winter you can capture the heat of the day to warm up your house. And on the next slide, you'll see that what it does do is that it really flattens the internal temperature into the building, and so the extremes are being taken out because of that dampening effect that the thermal mass of the walls are going to bring. So next, so this is the Witklipfontein Lodge. It's set in a World Heritage Site, and so we thought that we needed to create something that really respects the environment. The principle was really to lift a little bit the bottom of the hill that's on the right and to really slide the house underneath the hill. It's got a full green roof, which comes with weight, and the earth walls can deal with that. So this is another view. So on the back, it's completely invisible, and on the front, it does open itself so that from the house you can see the planes and things like that. We paid attention that the house still sits behind trees so that the fauna and the animals are not too distracted by the activity that happens in the house. Here you see the whole slope. It's one slope that really goes across the whole house, and you can see the stone walls that I'll talk to you about later. On the south side, on the north side, I'll get there. I'm still in Europe today. On the north side, everything opens so that your natural light can come in the building, and can come deep into the building. So what the high roofs allow you to do is that in the winter, with a 45-degree sun, the sun goes into the house about 5-6 meters deep, and we've got some dark floors that really capture the heat, and that heat gets given back at night in the winter. And in the summer, you don't have a problem because your sun is past the zenith or past the equator, sorry, and therefore is actually on your south facade. So you don't get any sun during daytime into the house. This is just a pretty picture of the rammed earth walls in different configurations in a knuckle of the house. So to enter the house, so we've just lifted the hill, as I was saying, and then you walk down along this tall wall, and you come inside the house, and you go down inside the house. To me, there's always an important movement into a house is to go from the outside that's very tall to go down through a passage, a door, an entrance, and then the space dilates again to give space for the living spaces. It happens with the door threshold, but here it's obviously seriously amplified. So building with earth. So the main thing that you need to know is that you need to have the right soil to be able to build with earth. If you've got pure sand, well, nothing holds and it just falls down all the time. We've all built sand castles along the beach and they don't stand. And even when you wet them a little bit, so to try to make them hold, once it dries, it goes flat. So pure sand is no good. Pure clay is no good either, because as architects or people in the building industry, you know that when you build on clay, when the clay gets wet, it swells, and when the clay dries, it drops and it starts cracking. So too much clay is also not good. And then there's the silt. The proportions you need to have an earth that you can build with is between 20 and 30% of clay. It's about 50 to 70% of sand and 10 to 20% of silt. That's really the perfect type of mix, and you can push that quite further. Now, if you are close to a river, you need to pay attention, or a riverbed, you need to pay attention that you don't have too much clay. If you are very much inland, far from everything, most probably you'll have a lot of sand. But testing is very easy. So there's about 9 hand tests that we use to test the quality of the earth. These are just 3 of them. The one is you put some soil into your hand and you just rub it a little bit in your hand. If you rub it and there's nothing in your hand, means that it's pure sand. Like on the beach, there's nothing left. So that's no good. If it's very if it sticks and it's very orange and it sticks to your hand, there's too much clay. And so as you learn about earth and building with earth, you very quickly, just by grabbing a little bit of soil from the site, you will see whether your soil conditions or your earth is correct, or whether you need to bring a little bit of sand or you need to bring a little bit of clay. Another test is the cigar test, where you really create, you moist slightly the earth, and then you create a long cigar. You push it over your hand or over the edge of a table, and you see how long it goes. So if it goes too far and it starts bending like that without breaking, you've got too much clay. If you push it and it breaks immediately, you've got too much sand. So those are 2 quick techniques. And then one that is almost compulsory is really the sedimentation test, where you put earth into a bottle, 50% water, you shake it well, you leave it for 3 days, you come back and you will see that all the different elements have actually layered into your bottle, with the water at the top, and then the silt, and then the clay, and then the sand at the bottom, and little rocks and things like that. And then you can really start seeing the proportions that you have. So those are hand field tests. Some people also use lab tests to be more precise. And if I've got time, I'll speak a little about some of the masters in building with earth. So into the house, what we wanted to do is to really create about 4 building techniques. And the building techniques with earth, the first one that everybody generally knows is the rammed earth walls. So if you go to the next slide, the rammed earth is really, you use some type of shutter. You can use wood shutter like in the past, and you will see that we used wood shutters in the first house that we did, and there was a lot of movement with the wood. So after that, we worked with steel shutters that we borrowed from one of our friends, contracting friends, and that works even better. So you put your shutters up, you put your soil, you moist the soil a little bit the day before, but it's actually not, it's just moist. It's not wet, it's not cement, it's not flowing, because you need to be able to compact it. And you create 300 millimeter of soil and you compact it down to 100. So you compact 2/3 down to get to the right level. You can compact by hand, and that's what we do with stampers. So we've got big heavy plate at the bottom, and then just a rod at the top, and we stamp the soil layer by layer by layer, and you go up that way. In Europe, they use a lot of mechanical stampers, so like a big drilling machine that stamps, but you can't use the machine where you do the roads with. That has got too much force and it pushes all the earth away. So you can't press too hard. There is something that you need to compress the earth, but you can't go beyond, and then it starts breaking and going all over the show. So those walls are extremely strong. One of the walls in the lodge has got about 6 tons per running meter on the wall, and it's a 5 meter tall wall. It's 50 centimeters thick, and just to give you an idea, 5 tons is about 3 or 4 large SUVs per running meter of the wall. So and that's because we've got a green roof. And in South Africa, our green roofs need to have a lot of soil, because otherwise nothing grows on it because it's too hot. So here you see the walls, how we will build them with formwork. Now it's very different from concrete, where you need formwork right to the bottom. Here you can see that the formwork climbs as you do your layers. So you actually need only one panel vertically. You need your verticals, but horizontally, sorry, you only need one panel, and you push that panel up all the time. We have got some ferrets like in concrete, so that when you stamp it, the shutters don't split, and so you do see ferret holes into a rammed earth wall. The next technique that we've used is the compacted soil brick. So this is a brick that is compressed. So it's not a brick like you see a lot in Africa, where they just put it, tap a little bit with their hand and then let it dry. It's also a good technique, but this is quite a strong brick. So it's just earth, and we compress it with a hand machine that you see on the next slide. So it's a hand machine over there that we found plans on the internet, made a cutting sheet, sent it to the steel guys. They got us the pieces, we assembled it, and we used the machine. 2 people can make more or less 500 bricks a day. So that gives you a little bit of how many bricks a day you can create. And then you build it like a brick wall, but no cement. So you don't use cement in between the bricks. You just put mud in between the bricks. So here you see our machine on the left. You see our bricks that are, so you need to compact them, and then you let them dry for 2-3 days, and then you put them up. What you can also see on the picture is that we had cleats, timber cleats in place, so that we could fix our doors and other elements of the house. Because obviously, I mean, not obviously, but these bricks are, you can't really drill something and hoping that if it's just to hang a frame, it's fine. But to have a door that you bang every day, it's not gonna withstand it. And that's why we have those brick cleats to hold our doors. Third technique that we used is the sandbag or earth bag technique, which is quite an interesting technique because it was developed by NASA to go and build on the moon, because the only thing that you need is the bags. And depending on the quality of your earth, on the moon it's pure sand, so they needed quite strong bags. But here we have an agricultural bag that is actually biodegradable. And before we finished the building, most of the bags were eaten by the sun, because they really serve as temporary formwork. That's really what happens. And if you go to the next slide, so there you bring the earth, and then you put it in the bags and you compact each bag. If you go to the next slide. So here you see how we are doing. This is a part of the house that is the dome, and that is a dome that is below 5 meters of soil. So there's quite a lot of pressure on that dome, and but its circular nature makes that it's very strong. You can see that we've devised a bucket. You take the bottom away, and you take all your sausage or your the fabric of your sausage, and then you put the earth in and you compact as you go. You see the stampers that we use in the middle picture, and then on the right it's a test that we did where we burnt the edge of the bag and we cut it off, and it gives you all a sort of a rammed earth, but also with the horizontal lines of the bags that are left. But if you go and see at that wall now, you don't see any of the bags anymore because it's being eaten by the sun. So that's the dome finished, which is a beautiful space, completely below the earth, so very very fresh, and it's really a good family environment where the kids play board games and things like that, or where I do my siesta in the summer. The fourth technique is just rock walls. So stone walls here, those stone walls are held with mud, so not with any cement. And obviously you can push it to the point where you've got dry walls without any mud, and you have just stone with little stones that are holding everything together. And you see that in old walls in nature or in the rural areas. But that's a very slow technique. This is a little bit faster, and it is as beautiful. The external of the wall, and I forgot to mention that the external of the rammed earth wall also, we put 3% of lime, and the lime is there not as a binding element but as a water repellent material, so it really pushes the water away. So in this case, what we've done on the outside is that we joint between the stones, and we jointed with a mud with 5% of 3 to 5% of lime. So we've finished this house about 10 years ago, and we had to redo the jointing once, especially on one wall that is receiving constant driving rain on it. So these are the stone walls and how they went up. One of those walls is about 6 meters tall, and that's where all the solar panels are hidden behind. But you can see all the elements of, so the stone, the earth, all that is found on site. The lime is something that is agricultural lime that all the farmers around us use as fertilizer, and so it's very easy to find. If you go to the Cape, you can even find active lime, which is even better, but on the Highveld it's very difficult to find active lime. Then a lot of the walls, so the rammed earth and the rock walls, can stay as they are, but the compacted earth brick and the sandbags, we finish it with a mud and straw plaster, which is really what it says. It's mud and straw, and if you can cut the straw into smaller bits, it's even better. That's why you also can use a cow dung, because cow dung, what it is micro chipped grass. And so cow dung is extremely good to make plaster, but you need a lot of cows to create enough dung to plaster the inside of a house. And then to finish it all up, we paint the plaster wall with the natural Swedish paint. It's called Swedish paint because it was used by the Swedes very long time ago. And in Sweden, you see the houses are red, blue, orange, and all different colors. And I can tell you it was like that before Dulux and Plascon existed. And it's just flour that you bake, water that you make to boil. You put flour in it, and a little bit of linseed oil if you want it more plasticized. And then any colorant that you want. Here we use the earth of the place to give us that brown earth. You boil it for about 30 minutes, and then there you've got your paint. The only reason why I think that has never been commercialized is because it's got a very short lifespan of about 2 to 3 weeks, after which the water and the earth just separate, and you can't do anything. The water and the flour separate, and you can't do anything to mix it back again. So, but otherwise, it's an extremely durable and strong paint that is made just of flour and water. Okay, so in the building industry, so people I always ask myself, why aren't we using that more into other than just specific or exceptional buildings like the lodge and things like that? Why is it not used more into the built environment? So the one thing is it creates much heavier structures. So the earth walls need a certain thickness. They are quite heavy, that you have to be aware of. And when you build 16 stories, at the bottom you'll have a meter and a half of wall, which is going to be nice insulating, but it's quite thick. It needs some maintenance. So any earth walls that are battered by water need some maintenance. The principle of building with earth is always to have strong wellies, so to protect the bottom of the wall, and a large head to protect the top of the wall. Now, because we wanted a minimalistic look, we don't have the wide head. We've got very little drips and things like that, which also works, but you have to be more careful when you do that. So the principle is good wellies and a good head. If you leave an earth wall exposed at the top, I can promise you it's gonna disintegrate. Whatever you do, it can be as well rammed as you want. It will disintegrate quickly. As I said, there is a very negative cultural preconception about to earth. Because it comes from a vernacular and because it comes from village, therefore people think that it cannot be brought into the cities or the larger scale buildings. So it's building techniques also that have been lost. So when we did this project, we decided not to use a conventional contractor because he would come with all his preconceived way of building, and we did it ourselves with farm laborers that we taught them all the techniques, and therefore they were building the way we wanted them to build, and not like a normal mason or a normal contractor would work. And obviously it's from economically, people always ask, is it cheaper? I don't think building with earth is cheaper, but there is a massive shift between the cost of the material that you buy, the baked bricks, the cement and things like that, and that money is shifted towards the labor. Now in South Africa, where we've got such a big population that needs work, I don't see why it's not used more, because all that money that you, in the traditional construction that you use into the building to buy materials, really shifts towards the labor. And there's a study done by somebody that builds with earth in, I think, Iran, if I'm not wrong, that really showed that did a clear exercise on that and clearly showed that shift of the budget from the one to the other. It's also slightly slower to build, but it's also something that you can build with the family and with people that don't have huge building knowledge techniques. So it can become a family projects, for instance, or like it was in the rural environment, the houses were built by the community, not by one person. They were building one house after the other together, and they are doing the maintenance one house after the other together. So there's quite a social effect to building with earth. So I need to wrap up. Thanks a lot, Marloes. Just the house here is complemented with a natural pool. That's actually an incredible pool to be in, where there's 2 filtration ponds and one swimming pond. This is the next slide is just to show another building that we've done that is fully done in earth bags. So we've discovered that earth bags is the cheapest and the fastest way to build with earth. And because this is an artist retreat that we built, we didn't want to spend too much money, and so we used that The nice thing about it is that you can build straight walls, but you can build any curve that you want, and therefore you've got those curves on the building that are very easy to make in earth-back walls. The next slide shows one of our neighbors that was liked what we were doing, and she went and did a rammed earth in a curve, which you can do, but you can see on the left that you need quite a lot of more specific formwork to do that, but it obviously is a very, very pretty and beautiful result. Next. And that's it. That's it a little bit about our adventure. I could speak hours about this. Yeah, and if there's any questions, please go ahead.
Thank you. That's awesome. Any questions from the audience? Just put up your hands. I don't know what your name is, but Specialist Writing Services?
Yeah.
Okay, you can hear me. Okay, sorry, yeah, it's Gareth here, Gareth Griffiths. That's one of my email addresses there. I just wanted to ask Xavier if you could please define silt for us, because there are obviously quite a few interpretations of silt as an ingredient in preparing your earth recipe.
So when you any soil will have some type of silt. It's even thinner grained than clay. Comes from organic material that being broken down. You don't want organic material into that can carry on breaking down. You don't want anything in your soil, because otherwise your wall is gonna move. But it's really the smallest particle of the component. So you've got the silt, then you've got the clay that's got a slightly higher granulometry, then you've got the sand, and then you've got the stones, and you can have all of it. So the one thing that I wanted to speak to, the master of building with earth is an Austrian guy called Martin Roch in Austria. And he works very scientifically, and he's got 9 granulometries in some of his buildings, but he builds 2-3-story buildings with walls that they've got, sorry, they're 30 cavity 30 type of thing. So he goes to the extreme. He's just built a 6-story building apartment building in France. Yeah, so the granulometry is quite important, and that's where the silt comes. The silt is really the thinnest of the granulometry of any soil.
Great. Any other questions? Come on, guys.
Marloes, you must have questions.
I normally have a list of questions, but this time I was so busy going through your presentation that I
sorry
write
for that.
something down.
Well, if you've got time, you've got still my little movie.
Right.
That
We still
takes
have it already. But no, before I do have a question actually. Milan, you browsed over it quite quickly, and it's something that I was reading up on lately, is this disconnect, the disconnection to nature, which is one of the major reasons why people can't seem to connect with climate change, or don't necessarily want to act on climate change, because as humans we've sort of lost that disconnect to nature. What is sort of your opinion about that, and how can we link that back to biomimicry and living buildings?
Great question. I think going back to those 3 seeds of ethos, emulation, and then reconnection was quite a key component. So again, I think just relating it back, there's this mindset of sort of extractive, and you can just sort of even just take from the environment. But when you start developing a relationship with the environment, when you start, cultivating sort of a one-on-one idea of you're part of the natural environment, it's not just nature and hue, and you have that lens shift, you start seeing actually that, we're part of a greater interconnected web or system. And now, if you translate that back to, say, the Living Building Challenge, it's not just a building that's separate from the ecosystem. Same with us. It's not just us separate from the ecosystem, but how do we relate to those things? How do we contribute to each other and not just, linearly? So it's quite a pivotal thing. And I mean, there's a lot of research done that says that we've lost words like moss and things, of these key natural words in our literature for the past 200 years. There's been a 60% decline. So globally, our connection to nature is declining, but there is a shift now. There's definitely conversations happening about how we can do that and reconnect, and just, it could be as simple as just engaging your senses next time you go for a walk, or something as simple as that. But
yeah, nice. And then Xavier, I've got a question for you. So you've worked mostly in the commercial industry and now doing this project. What was sort of your did you take anything back from what you learned on this lodge project back into the commercial project, even if it's like little things to make the commercial projects a little bit greener?
So
regenerative.
So a lot of our commercial projects have got a lot of the principles that I've applied in that project, but also in other projects from a spatial point of view, from how do you do your facades. We've explored a lot on facades in commercial environment, how you use the fresh air, especially on the Highveld, where 80% of the time the external air is actually the air temperature that you want in the building, and so on. So it's not completely disconnected, but I haven't been able to bring the building with earth into the project. I've been trying to convince a few clients. The one was almost there, and for a few months said, yes, let's do it, and then he backtracked. Because when we do our commercial buildings, and especially in Joburg, where we create very deep holes for all the parking, because we don't have a good public transport system, we are moving humongous amounts of earth. And if you could just take a fraction of that earth and reuse it into the building and not having to cart it away to the other side of the world or the city, that would be a great thing. But no, I haven't been able to bring it in, and I don't want it to be gimmicky. So I don't want to just create a rammed earth wall on the side, which I've seen on some buildings. It becomes a gimmick. I would love to have the opportunity to bring that at a larger scale. It is possible, but yeah, you need to have the appetite and applying that trust that what you will do is going to be good. There was a question I saw that popped up about, can you build with earth in the Cape? Well, all the earlier settlers' houses in the Cape were built with earth. There was no cement in those days. And obviously, I don't know if you know, but why are the Cape Dutch houses white? Not because of Plascon or Dulux. It's because they were limed. So when you go to a much more pluvious climate, you just need to protect the wall a little bit. And traditionally, it was done with active lime that they were putting every year on the building. And then every 7 to 9 years, they were peeling it off, replastering with earth, and then re-liming it. And then coming back to Martin Roch, the Austrian, he's building in Austria, Switzerland, and the mountainous part of France mainly, which is not the easiest climate, and all these buildings are there. So yes, you can build with earth in other climates and harsher climates from a pluviometry point of view than just the Highveld. And I see the foundation. So the foundation, we need to. It was a stone foundation that we used for the walls, and there you need to put 5 to 10% of lime. So you need to increase your lime. You use the lime a little bit as a binding agent, because it is a binding agent. used by the Romans already to do their cement and concrete. Not cement, concrete, because they had a concrete without cement and they were using lime. But the big thing there is that when you use 5 or 10% of lime, is that if you let it dry very quickly, it starts cracking and then your foundation will fall apart. So what you need to do, you need to cover it with plastic every day, moist it a little bit, and do that for about 2 weeks, 3 weeks. So you let it dry extremely slowly, and then it's set for life. So that's for the foundations. So no, there's no water. The only area where we've got traditional waterproofing is on the dome. There we put traditional waterproofing, and on the roof before we put the earth on top. That's the only modern waterproofing that we've used.
Yeah, there's a question in the chat for Milan. Do you think LBC full certification is feasible in South Africa yet, or just core and petal certification? And if just petal certification, do other rating systems provide more value to the client?
So just to answer the first part of that question, so I did do my master's thesis at Wits, looking at the Living Building Challenge, particularly in the South African context. And unfortunately, the cost aspect of it does become quite pregnant when it comes to getting certification, let alone the materials and everything else. So it's feasible if you have the right resources and those kind of things, but there hasn't been a successful full petal certification, from my understanding.
There's the school in Paarl, although I don't know if they ever finished the actual certification. I think there were 1 or 2 challenges with the testing some of the air quality stuff. Yeah, but what would be amazing is if we can adjust and amend the Living Building Challenge for our continent.
Context.
That's still on my list to do.
Yeah.
Hopefully I'll get it.
Is it a northern hemisphere rating tool again?
It is a very northern hemisphere rating tool. But the principles and the aspirations and the framework behind it is really great. So if we can just, come up with a task team for Africa that we can make it African, because I do think the principles are really amazing.
Yeah, you were speaking about air quality in the lodge. When in summer, it's very hot. It's in the northern Free State, so it's like 30, 40 degrees outside, and we managed to drop the temperature by 15 degrees naturally with the thick walls. What is quite counterintuitive is that you need to open everything at night and close everything during the day, because your walls have brought in so much coolth that if you open the windows during the day, then all that coolth goes away. But if you keep it, it's really like a fridge. And people always get into a room and they say, "What's happening here? Is there air conditioning?" They say, "No, there's no air conditioning. It's cold, but it's because of the coolth that we've captured during the night."
Yeah.
In the winter, people walk on the stone in the lounge, and they say, "Is there underfloor heating?" I said, "No, there's no underfloor heating, but there was good sun during the day, and the sun has been absorbed by the stones, and at night it's warm to your feet."
Yeah, nice. Yeah, that's proper passive design techniques, right?
Yeah.
Awesome. Okay, I think, guys, it's come to that time where we have to round off the webinar, even though I'd like to have this conversation for the rest of the evening. But just to give a heads up for next month, we are having 2 presenters, and the title is Beyond Green, Regenerative Luxury and Conservation in Practice. And we're gonna have a project that it's a luxury lodge in Africa, where, again, similar principles where they looked at the environment to make the buildings regenerative. And then we have a conservationist that is linked to the lodge that is going to tell us more about how the operations of the buildings are in line with conservation in the surrounding areas. So that's going to be an interesting one. And then in January, we'll kickstart the year with 3D printing in the built environment. So we're going to see on how we're going to use that technology to green the planet. So if you're interested, you can sign up for the November one. Ranjita will put the link in the chat box for where you have to sign up to get the emails. And then just to close it off, a really special thanks to our sponsor, the South African Institute of Drafting, who waived the validation fees for this webinar. I really appreciate that. And then a really big thanks to our speakers of today. You both did an excellent job, except for the IT skills of Xavier, but like, it is what it is.
Not of my age anymore.
It happens. Luckily, he sticks to architecture. No, thanks, guys. Really appreciate your time and sharing your project and experience and skills here. It's always good to hear some really good local examples. And then if you want to become a sponsor, or if you know a company that has too much money that wants to sponsor the Regenerative Collaborative, or just one webinar is also fine. We've got a sponsorship brochure and everything. So if you need more information about that, just let us know. And so we can continue in the year 2026 with our webinars. And yeah, don't forget to follow us on our socials. Every click and every follow helps us to hopefully secure that massive sponsor that we don't have to worry about that anymore on a monthly basis. So yeah, please like our socials and to keep up to date as well. So with that, thank you guys. Thank you for attending. Nice to see a lot of reoccurring people on the webinar. Yeah, we appreciate your attendance and your questions, and have a really good evening, and I hope to see you next month. Bye, everyone.
Thank you very much.